Hi, I am Chandrasekhar Gupta and we are talking about computer fundamentals. After discussing about the data types, I think it's the right time to talk about pointers. Generally, if someone asks you where do you live, you'll give them your address. Similarly, when you declare a variable and you assign a value in any programming language, it needs to have a memory location similar to address. That memory location is represented in hexadecimal format. If someone wants to reach you, they'll reach you with the help of your address. Similarly, if someone wants to reach our content and modify it, they can do it with the help of the address, which can be sent through them with the help of a special variable. And the special variable which can be used to store this address is called as a pointer. Basically, pointer is a normal variable where it tends to store address instead of value. Let's try to understand more about pointers and let's dig deep in this. Consider an integer a. It is having a value of 10. The memory in C programming language is aligned in terms of one-dimensional array. Let's assume it starts from 100 and so on. For the sake of simplicity, I am assuming that the integer is 1 byte here. Now, let's assume A has got a memory location of 100. So, A will be at a memory location 100 and it will be having a value of 10. Now, if we want to get the address of A, we can get it with the help of ampersand A. Ampersand A gives us the address of A, which is 100 in this case. A actually gives the value which is 10. Let's understand it with the help of a pointer. Consider an integer pointer and the pointer is pointing to A. This statement states that P is a pointer at some memory location, let's say for example 500, and it is pointing to A, means it is having the address of A as a content. If we want the content of P, if we write P, it will give 100. If we want the address at this location of P, we can write it as star P. Star P gives as star 100, which automatically decodes the address present at this location, which is 10. Similarly, as a variable is having the address, the pointer will also be having the address and it can be obtained with the help of ampersand P, which is equivalent to 500 in this case. Let's try to understand pointers with the help of an example given here. I have written a main program in which an integer is declared and I am passing an integer as an argument to a function. So, this actually takes the control to here and it is taking a value with it which is A and the value of A is 10. So, what happens here was initially this is the stack. Don't worry if you are not aware of the stack, we'll get to know it soon. Now, consider the main function call. Initially, the main function call will be made in stack. And what are all the variables which are declared inside the main function will be stored here. Suppose A is having a value of 10 and it is stored inside stack. Now, a function call has been made at this point. So, from this point, a function call will be made to fun function and it has taken the parameter of A with it. So, it will be taking the value of A. Here we are calling it with the value of A. So, this is called as call by value. And it actually created another variable and it changed the content of it to 20. Now, as soon as it finishes off the function execution, the function will be popped off from the stack. So, this will be no more present inside our stack and only the main will be present here. And as we have seen, the A value is still not modified. It is equivalent to 10. The value changed over here is in different address space and that has been removed from the stack already. Now, A value is similar to the first case and it has not been modified. So, the output of this program will be equivalent to 10. Let's try to understand one more example. Here also the main function was defined and we have defined an integer, but instead of calling with value, we are actually calling with address as value. People generally tend to call it as call by reference, but call by reference does not exist in C. This is also called as call by value, but we are calling with address. So the value which is used over here was address. And as we know that pointers are the variables that tend to store the address we have to define a pointer while receiving it. So the pointer was defined here. Means as we are sending the address, there has to be a special case of variable which handles the address, and in this case it is the pointer p. Let's try to understand this example in the same way similar to stack. So this is the stack and the main function call has been made. Initially a variable has been declared and its value has been 10. Consider 100 to be the memory location of A. Now a function call has been made and it is taking the address of A. So it is taking 100. And as we know that the address has to be placed in separate variable called as pointer. So a variable p is created and it is having 100. We know that star p actually points to the value which is at this address. So when I write star p, it decodes as value at 100. What is the exact value at the 100 is A. As value at 100 has been changed to 20, the value at A will be changed to 20. And the function is completed and the control returns here and the function will be popped off the stack. Now we are having a main function with one variable with the modified value. After printing it, the output here will be 20. Just try to understand why the output has been modified in the previous program and this program. That is because here we are actually passing the address of the value and we are tracking it with the help of a pointer, and we are updating the value of that address with the help of this pointer. That's the general use of pointers when we don't want to give the content directly, but we are tending to send its address so that the value can be modified from a distant point and it can be maintained throughout the program. After understanding the above example, consider this example. Here we are having two variables A and B and the values are 5 and 10 respectively. We have defined a function swap so that the value of A and B are interchanged respectively. If you don't understand swap program, let me just give you a brief overview. Suppose for example, you are having Pepsi in one container and you are having Coke in another container and the other container is empty. You just want to change the contents of one container to the other. What you generally do, you try to take Pepsi in this empty container. Now this empty container contains Pepsi and this is empty. As this is empty, you tend to transfer Coke to this. So the Coke has been transferred to this. This becomes Coke and this is empty. Now Pepsi can be transferred to this empty container and it becomes Pepsi and this becomes empty. If we just see, we have interchanged the first container and the second container with the help of a third container. This is swapping. Swapping is generally interchanging of two values, and in the same way how we have exchanged the liquids over here, we try to exchange it with the help of a temporary variable. We try to exchange two variables with the help of a temporary variable. We are passing 5 and 10 to this swap function, and if you just see, we are calling it with the help of the address of A and B respectively. Consider a stack here which is having the main function and it has two values A 5 and B 10. Consider the memory location to be 100 and 200 respectively. Now a function call has been made from here, that is swap function call has been made with the address. So 100 and 200 has been passed. A is storing 100 and B is storing 200. Let's say this is at the address location of 500 and 600 respectively. In swap function, a temporary variable has been created. Let's say it is at the address location of 700 and the temporary variable has been loaded with the star A. That means we know star A is at 100. So the value at 100. What is the value at 100? That is 5. So temporary is actually changed to 5 and star A is equal to star B. So star A is the content at 100 has to be equal to the content at B. What is the address of B? 200. So the content of 100 has to be the content of 200. So 5 will be changed to 10. Now star B equal to temp. That means that the content at 200 should be equivalent to the value which is at temp, which is 5. So this will become 5. After the control returns from here to here, actually this pops off and we don't have anything in the memory. Now we are left with A and B at 100 and 200 memory locations respectively with the value as 10 and 5. So the output of this program will be 10 and 5 respectively. Now you have a basic understanding of pointers and how does it happen in terms of stack. So let's try to understand further. The reason I am stressing on this topic was because most of the questions will be framed on this topic, and if you tend to understand this topic, you can solve each and every question very easily. Let's try to understand this. Consider the main function and a variable has been declared. So a variable has been declared, the value is 10, consider it is a memory location 100, and this is inside the stack and this is happening inside the main function. Now a pointer has been declared. Let's say this is a pointer which is at the address 200 and the pointer is storing the address of A. So pointer is having 100. Now here I want to talk about increment and decrement operators because people tend to have a misconception about this. The thing between increment operators is we are having two types of increment operators. First one is post increment operator and pre-increment operator. In terms of post increment operator and in terms of pre-increment operator, the value tends to increase. But consider this is a post increment operator and this is a pre-increment operator. Here if the A value is initially 5, this actually increases the value to 6, but it substitutes the old value. The value will be modified but the old value will be substituted. Here the value will be modified but the new value will be substituted there, then and there. How it makes a difference? Let's try to understand here. Now the value of A is initially 10. Here it is post, so it has to be incremented. It will be made to 11, but the old value has to be substituted. And when it comes to the second statement, here the value has to be incremented and the new value has to be substituted as it is incrementing using the pre-increment. So 12 will be printed. The output of this line will be 10 and the output of this line will be 12. Just try to understand, in terms of pre-increment, the value will be incremented and the modified or new value will be substituted. In terms of post-increment, the value will be incremented and the old value will be substituted. Let's try to dig further. Suppose, for example, here the value at this address location has to be modified to 5. So the value of P is 100. So the content at this location has to be modified to 5. So the value will be modified as 5 here. Now I am trying to print the value content at this location which is equivalent to 5. Similarly, if I am trying to print the value of A, it is also equivalent to 5 and 5 will be printed. Let's continue it. Suppose for example, we are trying to modify the value at this position. So we are trying to modify the content at the location of 100 and we are trying to add or increment it by 7. Let's assume the value is initially 10 and it has been modified to 17 now. Now if I try to print the content at the location of 100, it is equivalent to 17, and if I try to print the value of A, it is also equivalent to 17. If I try to get the address of A, ampersand, just remember ampersand is used to get the address. So if I try to get the address of A, it is 100. So 100 will be printed here. Let's try to understand this further with some more examples. I have taken this for our reference. Let's assume the value to be 10 initially. Now in this case, I am trying to get the content of P initially. So the content at the location of 100 is equivalent to 10 and I am applying a post decrement operator on it. We know that in the case of post decrement, the value will be decreased and the old value will be substituted. So the value of A will be made to 9 and the old value, if you are trying to print the value in this statement itself, 10 will be printed, but the value will be changed to 9. And now if you just observe in this statement, I am trying to print the value of P. That means I am trying to get the value of the address which it is storing, which is 100. If I try to get the address of pointer, you just need to remember that pointer is a variable which is storing address. So as it is storing something, itself in turn it will be having one more address, and we are trying to print that address in this statement, which is 200 in this case. So the output will be 200. Now if I am trying to get the content at the location of 100, it is 9. Let's observe the statements. Here I am trying to get the value of A, so it will be 9. I am trying to get the address of A, which is 100, so 100 will be printed. And if you observe the statement carefully, I am trying to get the content at a location of 9, which will be generally some value, so it tends to have a garbage. We have discussed a lot about pointers, and before working with the pointers, there are some of the things you need to understand. Let's take for example, if you are having an integer pointer or if you are having a character pointer, both of them tend to have the same size. That is because if you just remember, pointer is storing the address, and address in C programming is hexadecimal digit, which is an unsigned integer. So all pointers is of uniform size. This statement means that even though if it is an integer pointer or even though if it is a character pointer, every pointer stores the address and the address is of the format unsigned integer. So all pointers are of uniform size. This point is very important. Just try to keep a note of it, and you just need to understand that return type of any pointer is void pointer. That is because if you are trying to store an address inside a pointer, it doesn't know that what is actually this address is for. This address can actually point to array, or this address can actually point to an integer, or this address can actually point to a character, and so on. So how do you distinguish what is at this address location? That can be distinguished with the help of the type of pointer. If it is an integer pointer, integer can be found at that address. If it is a character pointer, then character can be found at that address. Similarly, if it is an array of integers, then it will lead to us an array of integers. As simple as that. Now, if we want an array to store different data types, consider this array, and this array I want, first thing I want to have an integer. After that I need to have a character. Later on I need to have a long int, and after that I will be having an array of integers. Can you find out a way to make this possible? If you observe carefully, we can actually declare an integer pointer here, and character pointer here, and long int pointer here, and array of integer array pointer, and we can tend to store their address, which is having uniform size, and so we can even declare an integer array. Okay, and integer and unsigned integer are of same size, so we can declare an integer array, and each and every location can point to a pointer, and this will actually lead us to the value respectively. So in this way, in a single array, it is possible to store different data types. We have talked a lot about pointers, and it's time to wind up this session. But before that, have you used arrays in programming? And have you ever passed arrays as an actual argument to a function? Have you noticed some difference? Even though when you pass array through call by value, the entire value tends to be same. It acts as call by reference. Why do you think it happens? Stay tuned to find out.